Everyone, today we are going to run the problem of IRR. This slide shows MPV profiles. MPV profiles means a graphical representation of project MPVs at various different cost of capital. The cost of capital means what? The cost of capital means the WACC, right? So to plug in different WACC, you get the different MPV. So for example, the first WACC was the 10%, right? So when you input this R, 1 plus R, then you get MPV, $18.7. Then that is round up to 19, right? And you can input the different WACC, for example, 15 or 20, input here, right? That is about this R, the WACC. So repeat this process, plug in different WACC, you can calculate all the MPVs. So as you can see, when WACC increase, MPV goes down, right? It means what? When cost of capital increase, the net present value goes down. This graph shows the MPV profiles. So x-axis means the discount rate, the WACC, and y-axis means MPV. So the discount rate is the WACC. For example, the WACC is 5, MPV L is 33, MPBS is 29, so WACC is 5, 33, and 29, here and here. And you can dot all the points and draw a line. That is MPV profile. Interesting concept is crossover point. The crossover point is two projects MPV are same each other. So when WACC is 8.7%, in this case, MPV of project L and MPV of project S is same. I already uploaded this Excel exercise file. You can download this Excel file. And here is crossover rate. The first three, if you want to calculate crossover rate, just subtract these two cash flow, the project L's cash flow and project S cash flow, and this subtract these two, you get some numbers, right? Like this. And then the IRR function the input the range of all the cash flow, right? And then you get 8.7%. That is a crossover rate. In this WACC, MPV of project L and MPV project S are same, right? Here is one important question regarding this graph. IRR method and MPV method lead to same direction? The answer is it depends on. It's always the right answer, right? Do you remember what condition did when you accept the project, the MPV method and IRR method? Yeah, MPV method, MPV should be larger than 0, right? In this case, we can accept. And IRR method, the rate of return, expected return should be larger than the cost, right? The cost is WACC. In this case, we can accept, right? So let's assume we have independent project. It means we can choose as many projects we want. So let's check the both method read the same direction. So the first case, the MPB method, as you can see, when WAG changed to here and here, the project L case, the MPB has a positive number, right? And project S case, when WAG change here and here, MPB also always positive number. So we can accept both project, right? In the IRR method, they can say accept if the IRR larger than cost of capital, right? So firstly, the project S case, IRR is 23.6 and WACC moves from 0 to here, right? So for example, this point, IRR is 23.6, but WACC is only 5, right? So we can accept this project. How about this? The WACC is only 20, but IRR is 23.6, so we can also accept. So from the IRR methods, IRR always larger than WACC, so we can accept project S. What about project L? Project L, IRR is 18.1. So for example, this point, IRR is 18.1, but WACC is only 5, so we can accept this project. And what about this? IRR is 18.1, but WACC is only 15. So return is more higher than cost, so we can accept project L. So we can conclude that if the projects are independent, it means we can choose as many projects we want. So two methods, IRR method and MPB method, always lead to same accept reject decision. So no problem when we have independent projects. We can use the both methods, IRR and MPB methods. The problem occurs if projects are mutually exclusive case. It means what? Yeah, we can choose only one project. The problem occurs here, the left hand side of crossover point. According to the MPB methods, both are positive number, but we can choose only one project, right? Because the projects are mutually exclusive. So in this case, we can choose only one. So which one is higher? Yeah, higher MPB is project L, right? The red number, project MPB L. Larger than MPBS. So we can choose project L. But IRR methods, which one is more larger number? IRR S is more larger than IRR L, right? Because project S IRR is 23.6, but project L's IRR is only 18.1. So in this case, according to the MPB method, we choose project L, but depending on IRR method, we can accept only project S. So there is some conflict, right? Which one is right? We will talk about this later. And the right hand side of crossover point here, in this case, the WACC is larger than crossover rate. And this case, its WACC is smaller than crossover rate. For example, crossover rate is 8.7, but this case only 5, right? So let's check this case. This case, MPBL and MPBS, which one is larger? MPBS, right? Because it above the MPB of project L. It is here, right? So we can accept project S. And what about IRR? IRR L, IRR S, which one is larger? Yeah, IRRS, right? Because IRRS is 23.6 and IRRL is 8.1. So we can accept project S. Yeah, there is no conflict, right? So no conflict. So only conflict occur this part when WAG is smaller than crossover rate. There is some conflict. So we can conclude that the projects are mutually exclusive. It means we can choose only one project, and when WAG is larger than crossover rate, this case, right, there is no conflict, right? So we can conclude that the MPB method and IRR method lead to same decision, right? So we can write as this. Two methods leads to same direction. But if the WAG is smaller than crossover rate, this case, right, the WAG is only 5 and crossover rate is 8.7%. In this case, there is some conflict, right? So we can conclude that two methods leads to different decision. Why this problem occur? And next slide, it explains two reasons. The first one is timing difference. If the most of cash flows from one project come in early, and while most of those from the other project come in later. In this case, MPV profiles may cross and result in conflict. Yeah, in our example, the project, the cash flow occur more earlier. For example, at T1, the cash flow occurs 70, right? But project L, at T1, the cash flow only 10. But project L, cash flow occur more later. At T3, they have 80. But project S, at T3, they have only 20, right? So in our example, project S, cash flow coming more early, and project L, the cash flow coming later. So in this case, there is some timing difference. MPV profiles may cross and result in conflict because discount rate affect more when project is wrong. Condition is size difference or scale difference. It means if the amount of invested in one project is larger than the other, these two can lead to profiles crossing and result conflict. Here is one example. Suppose we multiply the cash flow of the project L. So now I already calculated these numbers. Then what happened to MPV or IRR? Yeah, at the original number, the before I multiply 10 times, MPV is 18.78, right? And after multiply 10 times, yeah, it has more larger number. Yeah, it increased 10 times. What about IRR? Yeah, IRR does not change, right? Because it is expected rate of return. Even though the cash flow size increase, the rate of return is same. But MPV changed, right? So the project size or scale difference, it may lead to profile crossing and resulting conflict. So we can conclude these two basic conditions cause MPV profile to cross. There is a conflict between MPV and IRR method. Which one is better? Yeah, the answer is MPV is better. Why? MPV is correspond to objective of firm. What is objective of firm? Maximize the firm value. It means maximize the stock price, because stock price is one good measure of the firm value, right? And stock price increase, it means maximize stockholders' wealth. MPV represents what? Do you remember this, right? Yeah, this MPV represents net gain in wealth. So how much contribute to the shareholders' wealth, right? So it is correspond to objective of firm. So we can write this is net gain in wealth. So we can conclude that MPV is the single best criteria because it provides a direct measure of the value the project ought to shareholders' wealth. However, sometimes IRR is not consistent with objective of firm. So now we are going to run the problem with IRR. Now, there are three problems when you use the IRR. The first one is IRR method is not consistent with objective of corporation. This case, net gain in wealth is more larger in project L, right? So we should choose L, but when we use the IRR method, we choose project S. It is not consistent with the objective of firm. The second problem is it is possible to have multiple IRRs. Here is example of multiple IRR. The project P has cash flows as this. Cash flow at zero, $800,000, right? And cash flow at T1, 5 million. And cash flow at T2, minus 5 million, right? So there is 2 times sign change, right? This is negative, positive, and negative. In this case, the multiple IRR problems occur. So let's check together. How to calculate IRR? For example, MPV case, the MPV, how to calculate this? Cash flow minus 800 $5 5,000 minus 5,000 1 plus what kind of discount rate here? WACC, right? Power of 2. But now we want to calculate IRR, so the MPV change to 0. What is discount rate? IRR, right? Right? It's the quadratic equation, right? Like ax squared bx plus c. In this case, solution is what? 2, right? When you solve that problem, you get two solutions. The first one is 25% and second one is 400%. The equation can write as this: ax squared bx plus c, right? So in this case, how many solutions here? Yeah, two solutions. So in this case, we have 2 IRR. When you solve the equation, you can get two solutions. The first one is IRR 1, 25%, and second one is 400%. But big problem is we don't know which one is meaningful, so we don't use the IRR. These numbers, these solutions can be also calculated using Excel. This is Excel exercise file. I already input the cash flows and apply the IRR function. The first case, just input the cash flow at T0 to T2, right? And then get the number 25%. And second one, there one more term, right? The IRR, and input the cash flows, and we can guess. I input the 3, it means 300%. So IRR function shows the closest number. So we get the second solution, that is 400%. But as I mentioned before, we don't know which one is meaningful. When multiple IRR problem occur, two or more signs change. So non-normal cash flow stream. As you can see, from here to here, sign change one time, from minus to plus, right? And here and here, the sign change one more time, right? From positive to negative. So sign change 2 times. We have the quadratic equation, and we have multiple IRR problem. So the normal case, the cost followed by series of positive cash inflows. So there's one change of sign. Like this, the project edge case, there is one cost and its sign change only one time, and from T1 to after that time, there is no sign change, right? So sign change only one time. In this case, we have only one IRR. Normal cash flow stream, the cost, the negative cash flow, then string of positive cash flow, then cost to close the project, like this, minus cost, and at the end there is also cost. close the project. For example, nuclear power plant. So when you invest in nuclear power plant, at the end there is a large cost of recycling plutonium, right? So it needs large cost when you close the project. So if you have a non-normal cash flow stream, you cannot use the IRR method. And the third problem when you use IRR method is reinvest rate assumption. Explanation about the reinvestment rate assumption. It is a little bit hard to understand the reinvest rate concept. So I would like to show you one example. So let me draw a timeline. When you have the $100 and there is 5% interest rate, and now you want to calculate future value. In this case, we can compound with the interest rate, right? So 100 multiply 1.05, then you get this number. How about the opposite case? When you have $105 at T1, and now you want to know the present value. In this case, you discount with the discount rate, right? You use this interest rate, right? So when you calculate the present value, we are implicitly assuming that cash flows can be reinvested at a specified interest rate, the 5% here, right? According to this example, when we calculate MPV, it discounts with the WACC. It means it reinvests with the WACC. But IRR case, it reinvests with what? IRR. Yeah, that is the different thing. So MPV method assumes cash flows are reinvested at the WACC, but IRR method assumes cash flows are reinvested with the IRR. The WACC, IRR. So cash flows are reinvested at the opportunity cost of capital. This is what? The WACC, right? So when you borrow some money, the cost is weighted average cost of capital. So when we don't use that, there is some opportunity cost. So it's more realistic. So we can conclude MPV method is better. So MPV method should be used to choose between mutually exclusive projects. So if you want a rate of return measure, the IRR, you should use modified IRR that utilize the cost of capital can be used. So the cost of capital is what? The WACC. Now we learn more deeply about the modified IRR. So MIRR is a discount rate that causes the present value of project terminal value to equal the present value of costs. So terminal value is found by compounding inflows at WACC. That is the point. So MIRR assumes cash flows are reinvested at the WACC. Example of calculating MIRR, the project L. And left hand side is present value of cash outflows. So you can take absolute number of present value of cash outflow. In this case, cash outflow is only here, right? At T0. And right hand side, the numerator is terminal value of, this is terminal value of cash inflow. So here is cash inflow, right? So now you calculate the future value of these three. So this is 880, right? And this number, the future value is 66. Where this number comes from? You reinvest with what? The WACC. WACC is 10%. So this number comes from 60 multiply 1.1. And this number 60 compound how many times? 2 times, right? And then sum of these three, that is terminal value of cash inflows. And then you should discount with what? MIRR. Should discount with 1 plus MIRR power of n. What is n? The life of project, right? So this project life is 3, right? Then when you solve this problem, you get 16.5% number. Train one more time with another example, the project P. So let me draw a timeline again. 0, 1, 2. Cash flow is minus 800. No. 5,000. Minus 5,000. And 10%. That is what? WACC. And now we want to calculate MIRR. So as I mentioned before, MIRR, the general equation is absolute value of present value of cash outflow. What is cash outflow here? The negative number, right? So you can write as this. The left hand side 800, and this number goes to left hand side, and it should be discount, right? We want to calculate present value of cash outflow, so it should be discount with the WACC. How many times? 1, 2, right? So power of 2. It is same with what? Terminal value of cash inflow, and then it should be discounted with what? 1 plus MIRR power of n. So there is only one cash inflow. This number should be compound 1 times, right? That is the terminal value. So 5,000 multiply 1.1, and denominator is 1 plus MIRR power of what? N is life of project. So this project is life is 2, so power of 2. And then solving for MIRR, that is the answer of this question, right? You can also calculate using Excel. The function name is MIRR. The firstly, you input all the cash flow from T0 to T2 here, right? And there is one interesting two types of rate. One is finance rate, and second one is reinvest rate. Reinvest rate, we already assume that is the WACC, right? And what is finance rate? It is regarding the cost. So if you invest this project, you need some money, right? So you can finance at some rate, But in this stage, we assume finance rate and reinvest rate is same. So both are the WACC. So when you input these three variables and then put enter, you get the MIRR 5.6%. So this MIRR is 5.6%. I used MIRR versus IRR because MIRR assumes reinvest rate at the opportunity cost, the WACC. So it is more realistic assumption. And second, the MIRR also avoid the multiple IRR problem. When there is non-normal cash flow, we have two solutions when we use IRR method. But when we use MIRR, there is only one positive solution, so we can avoid the multiple IRR problem. So for managers who write the rate of return comparison, MIRR is better for this than IRR method. We use the MIRR instead of the IRR. Yeah, the project P case, yeah, this example, right? MIRR is 5.6% and WACC is what? 10%. In this case, we can accept this project or reject. Yeah, MIRR is kind of expected rate of return. Right? And WACC is what? That is the cost, right? In this case, cost is more larger than expected rate of return. So we should reject this project, right? And when you calculate NPV of the project P here, yeah, you input the WACC and then the second variable is cash flow at T1, not a T0, right? You should calculate separately because T0, it does not need a discount. So it starts with T1 to T2 and then summation of T0. Then you get this negative number. In this case, we should reject this project, right? Because it has a negative number. So we should reject. So when we use the MIRR, we can get consistent with the MPV rule. Both methods lead the same result, right? Until now, we run the programs with IRR. So these two programs possible to have multiple IRR and reinvest rate assumption. It can be solved by MIRR method. So when you use the MIRR method, you can solve this problem. This slide shows capital budgeting method used in practice. This is old survey because the end period is 1999. Yeah, this comes from our textbook Brian Houston's. One interesting is at the 1960 payback period, it has large proportion, right? The company usually used payback period long time ago, but at 1990, MPV and IRR method is commonly used. As we learned before, MPV is a single best criteria because it provides a direct measure of value the project added to shareholder wealth, right? But why the firm still use the IRR? Because it is intuitive information. It measures profitability concept expressed as a percentage rate of return when they invest the project. So it's interesting to make a decision. So IRR contains information concerning a project safety margin. So the condition is IRR should be larger than WACC, right? It means expected rate of return should be larger than cost of capital. And then we can rewrite this equation as IRR minus WACC. And this is safety margin. So when they invest this project, they can earn this amount. So it is easy to understand. So IRR still commonly used in practice. Summarize this chapter, the project evaluation. So we can write as this, the project evaluation. We call this the decision tree. So there is some projects. We have two types of projects, right? So first one is independent. Second one is mutually exclusive. The independent case, we can choose all the projects, right? Not one project. So there is two types of cash flow. The first one is normal cash flow. In this case, MPB rule and IRR rule and MIRR rule, it is same result. So it doesn't matter, any of these are fine. And the second case is non-normal cash flow case. In this case, what problem occur? Yeah, multiple IRR. So we cannot use the IRR. Cannot use IRR. Why? Yeah, there is more than one solution. So we should use MIRR. So MPB rule is same with MIRR rule. What about the mutual exclusive case? We can say this also ranking. Rank, we can choose only rank 1, right? So in this situation, there are some conflict, right? Because MPB rule and IRR rule. And sometimes it does not same with MIRR rule, right? In this case, which method is good? Yeah, MPB, right? MPB is the single best criteria. So MPB is correspond to objective of firm in maximizing firm value because it provides a direct measure of the value project added to shareholders' wealth. So it is more consistent